Overall, the purpose of this video is to help you have a framework to think about the determinants of education. I want to begin with a quick review of indifference curves and the utility maximization problem that you probably did ad nauseum in Econ 1 and other econ classes, but I still think it's worthwhile beginning with that. Here we have a graph in the consumption and leisure spaces, but for our purposes, let's just begin thinking them as if there are any two commodities, C and L. So an individual has preferences that have some utility representation U of C and L, and this gives you how much happiness they have for each combination of consumption and leisure. Now, an indifference curve is drawing out all the combinations of consumption and leisure, or C and L, that give you that exact same level of utility. So typically we'll have nice smooth preferences like this, and all along this indifference curve are all the different combinations of C and L that make you equally happy, and utility is increasing in consumption and leisure, so that the utility curve I've drawn right here, which we'll call U prime, means that they're happier, people are happier in U prime than they are with U bar, since that has lower utility. With the usual utility maximization problem, we'll pick the highest level of utility that we can possibly get given the money we have to spend. So good C will have some price P, and we'll say good L has some price we'll call W, and those two have to add up to some total amount Y. Plotting this budget curve then in consumption leisure space is as simple as rewriting the budget constraint so that we have consumption is equal to Y minus WL divided by P. And notice that another way to write that, of course, is Y over P minus WP over L. So this is going to be a line where the intercept of the consumption axis is Y over P, and then that line is sloping downwards with a slope that depends on the relative prices. And we know that a consumer who's maximizing utility will choose the indifference curve that's just tangent to the budget constraint. So it looks like none of the indifference curves that we've already drawn are feasible. We'd wind up with some indifference curve. Maybe that one looks like the right one there. Terrible artwork. But that gives me some optimal choice of L and some optimal choice of C. Now we'll solve this classical consumer problem, recasting it as being about the choice of consumption and leisure, as opposed to the previous illustration where just C and L were any old composite goods, or any example you might have remembered and loved from the first time you had Econ 1. So in this instance, we still have preferences that are defined over consumption and leisure. Now, your consumption comes about through working. We'll call big L work. You get paid a wage W. So your consumption is purely driven by the amount you work. So W times L. What's different when we start talking about this as a time allocation problem is that amount that you work, L, is limited. You can't work an infinite amount. And notice one of the things you get utility from is, of course, consumption, but also leisure. You can only consume leisure if you aren't working. So we have, in this instance now, a time constraint where leisure plus labor have to add up to some total amount T. Now here, in this setting, we have a problem that's a little different than the last one, because your consumption depends on how much you work, and that's an endogenous variable. That's something else you're choosing. What we'd like to do is rewrite this problem as being one of maximizing some objective functions, that's your utility, subject to a constraint that relates all of the choices you have, which is consumption, labor, and leisure, to things that you're given. In this case, the only things you're given are the wage and your time endowment. Now notice we have a bit of a problem, we might think, because we have three things we're choosing: consumption, labor, and leisure, but just two constraints. So three unknowns, two constraints is a bit of a problem, but realize, of course, that the time constraint means that if you pick either labor or leisure, those two have to add up to t. So once you pick one, the other is fully determined. So really, it's just a matter of picking one of those two and your consumption. But notice that since your consumption is just a function of how much you work, really we only have one unknown. And we can plug in our time constraint into our budget constraint and get what we call our full income constraint. So let's do that. Let's plug in for labor. We'll define labor as equal to t minus leisure. That's just from rearranging our time constraint. Now plug that into our budget constraint, and we have consumption is equal to W times T minus L is equal to WT minus WL. Whoopsie, I made a mistake there. That's supposed to be a leisure. And now, to make this look like a budget constraint, I want all the stuff that I'm choosing on one side and all the stuff I'm given on the other. So I'm just given this WT. I'm choosing consumption leisure. So C plus WL is equal to WT. And that relates my choices to what I'm given. And that we call then my full income constraint. Now notice one thing that differs in this setup from the previous example when we just had this as a generic consumer choice problem is I went ahead and defined the price of consumption as 1. Okay? The reason why I did that is because it's easy to think of consumption as just being, the sum of all the things that you spent money on. Well, you got to add those up, and by adding them up, you can then think of consumption as being denoted in like dollars, and so the price of $1 is just 1. So it's easy. It's a simplifying assumption. We don't have to have an extra parameter floating around, and it makes sense how we framed the problem. Now to do this graphically, I can just draw my full income constraint in consumption leisure space. So notice if I consume no leisure, the amount of consumption I can afford is WT. And if I consume nothing but leisure, I obviously can't consume anything, and the amount of leisure that I can maximally consume in this instance is T. My choice of consumption and leisure now is just going to be the place where my the highest indifference curve that's just tangent to my full income constraint. So if this are my preferences, I wind up with some U bar, and that gives me the optimal amount of leisure and the optimal amount of consumption that I choose. And the slope of the indifference curve is the marginal rate of substitution. The slope of the budget line, in this case the full income constraint, is the marginal rate of transformation. So you still have that marginal rate of substitution equals the marginal rate of transformation. In this case, the marginal rate of transformation is the rate in which you can transfer leisure into consumption, which is W, given that if you give up leisure, you work, and then that allows you to buy W units of consumption. Now we'll add one wrinkle to the problem, which is that we have non-labor income that we can consume out of, meaning it becomes possible to not work and still consume. We'll call this non-labor income Y, and you can see it's been added to our budget constraints. The amount that we consume, C, is still the sum of all the money we earn from working, W times L, plus now that non-labor income, Y. We're still faced with the time constraint. The way we're going to solve this, as before, is to rewrite our budget constraint and our time constraint so that we have a full income constraint, plugging in, again for labor, And I plug in always for labor because I'm drawing this in consumption leisure space. So plugging in for my time constraint into my budget constraint and rearranging, I get my full income constraint. That is my consumption plus the amount of leisure that I consume is equal to the value of my time endowment plus my non-labor income endowment. And it's worth noting in this example that any unit of leisure I take implies, through the time constraint, foregone income. So then the price of leisure is the amount of that foregone income. That's what W is. So there is a price for leisure, even though it's not directly purchasable in a market because you're giving up consumption to consume it. The price of it is how much consumption you have to give up, which is the wage. Likewise, though you're never physically given a time endowment to hold in your hand, in practice you could convert all of that time you're given into work. W is the amount you get per unit, so W times T is your time endowment. Representing this graphically, let's say that Y is the amount of consumption that you can afford given the endowment that you have if you're not working at all. So all this really does is it shifts up the intercept of the axis by the amount of the time endowment. So this would still be the spot that you wind up if you were to consume all of your time endowment as leisure. It's just now you get some consumption. So drawing our full income constraint again, now the intercept is WT plus Y. And obviously the gap between this intercept and Y is the income that you could potentially make from working. All right, problem is the same. We still have preferences. We still wind up with some spot where marginal rate of substitution equals marginal rate of transformation, which is our optimal amount of leisure and our optimal amount of consumption. So in all likelihood, everything we've done so far you've seen. Now we're going to use this framework to think about education decisions, and we'll take into account that insight from the Schultz reading that's on Canvas, that one of the main costs of going to school is the work that you have to give up. That's sort of the opportunity cost of schooling. So we'll start with a model of free schooling, where you don't have to pay anything for school, but there's still that time constraint. And here, because we're not going to really be interested in the substitutability between leisure, schooling, and labor, we won't add 3 things to our time constraint. We'll just recast the problem we just did, but instead of leisure, we'll have schooling S. And so nothing changes. We still have our preferences. You see now it's S and not L. There's still that budget constraint, your consumption. Let's leave endowments in. So your consumption depends on how much you work and your non-labor income. Now your time constraint's a little different. So your time constraint is L plus S, time in school, adds up to your total time endowment. So we plug in our time constraint into our budget constraint to get our full income constraint, which now we have C plus WS is equal to your time endowment, WT, and your non-labor income, Y. So free schooling still means you have to pay for schooling, and the payment is the opportunity cost of that time, the other things you could bring in. And the Schultz article, which is the kind of first formulation of the human capital model, is exactly this. He just took the classic labor supply problem, redefined leisure as schooling, and then noted, hey, even if schooling's free, you still have to give up the income you could otherwise make. And so this is kind of the casting that you see from that problem. So rewriting, we still have, redrawing, we have the same problem as we had before. We have some intercept Y, some time endowment T, some full income constraint, and we choose consumption and leisure to maximize our utility given that constraint, which gives us some optimal choice of schooling, some optimal choice of consumption, and otherwise it's the identical problem we just saw. We've just renamed things. Now we're going to do the same problem in the consumption schooling space, but we will allow schooling itself to entail direct costs. So we have the same preference we had before in U of C of S. Now our budget constraint means we're going to buy consumption, which will have costly at 1, and we will have to buy some schooling, which costs a unit of P for each unit of schooling you buy. That's got to add up then to the money you have, which is the money that you earn, plus your non-labor income, and we still have our time constraint of schooling plus labor is equal to T. Now plugging in and rearranging for C and S, the two things we get to choose here, we have a full income constraint that is C plus, notice now there's two components to the price of schooling. There's the direct cost and the income that you have to give up. And those relate to the endowment of time and your non-labor income. This leads to a slightly different visual representation, because now if you spend all of your labor endowment as schooling, you can still consume, but you can't consume Y anymore. Instead, you can consume Y minus what you have to pay directly for schooling, which is Y minus PT. So that is now our new minimal spot on the consumption path when you've given up some consumption to spend all of that time endowment as schooling. And so we still then have a full income constraint. Notice the intercept up here will be when schooling is 0, so our intercept is still the same as before of WT plus Y. Same basic problem, we're still maximizing utility subject to my full income constraint, and that gives us some choice where marginal rate of substitution equals marginal rate of transformation. So that gives us S star and our optimal amount of consumption. It may for a moment seem like, oh, nothing's really changed, we've just shifted down, the amount of consumption you can afford when there's no, when everything is going to schooling, because you have to pay for that schooling, and that's true. But the really neat part of this change in the model now is what happens with a change in wages versus what happens in a change in the cost of schooling. So let's think about that. So remember, the cost of schooling, what happens with the change in direct cost of schooling. So the cost of schooling is the sum of the direct cost of schooling and the opportunity cost of schooling. So a change in wages and a change in direct schooling costs lead to different effects, because wages also appear on your full income constraint. So if schooling were to suddenly become more costly, but the opportunity cost, so the direct cost of schooling were to increase, but the opportunity cost of schooling didn't change, so wages were fixed, we wind up with a rotating budget line. Whereas when we change wages, W, we actually change the intercept as well. to make this really simple, let's just write it out. So suppose that S is equal to T. So I'm just trying to find out what this bottom intercept down here is going to be. So if S is equal to T, then my consumption is C plus P plus W T equals WT plus Y. Rearranging that, we have the WT's canceling out, so we wind up with C is equal to Y minus PT. So notice, with a change in wages, W, the intercept, when all consumption is based on, when all available time is spent on schooling, doesn't change. So now, in this setting, when wages go up, there's a new intercept here. We'll call that, say, W low T plus Y. But that's still going to connect to the same point that we had before. So the end result is that the impact of a change in the direct cost of schooling, P, in the opportunity cost of schooling, W, while similar, are not symmetric. You end up responding differently to P and W, and the reason why you end up responding differently to P and W is because with W, there's a change in the value of the endowment. So we call that an endowment income effect. Endowment income effect. So that's the change in consumption that results from the fact that you now feel poor when there's a change in the, or richer, depending on which way it moves, when there's a change in the value of something you're endowed with. Now I want to write out an algebraic version of this problem, just so we have kind of a simple equation that will summarize all the different things we want to think about when we're thinking of the problem of how much schooling to have. So we'll write out our preferences, which are defined, again, over consumption and schooling, as being a function of the present value of the future returns to schooling, which we'll say have the following form: m times the log of z, where z is that present value of the return to schooling, and m is the weight that our decision maker places on that present discounted value of the return to schooling. Usually we'll think of this as a model where we have a parent who's the agent, who's making schooling decisions for the child, and that Z is that child's future well-being that comes about through the parental investments in schooling. And M then is the weight that the parent puts on that child's future well-being. And typically we'll assume that M is less than 1. Think about the implications of that going forward. The other part of our preferences, of course, are not just schooling, they're also consumption, and we'll say that the parent puts some weight Q on their current consumption, and they get utility from that of a log form, log C. Okay, so that's our objective function. Now that standard of living for the child in the future that arises because of returns to education, we'll say it's of the following form. The log of Z is equal to A plus BS, where S is schooling. Let's think of that in years. And so I should ask yourself, what's the interpretation of A? What's the interpretation of B? And you should be able to figure out those, very least, by totally differentiating this child standard of living equation that we've written out here. We have the same full income constraint that we just derived. So that's C C is equal to WT, your endowment of time, plus your non-labor income, minus your spending on school, which depends on both the opportunity cost and the direct cost of schooling. Now if we plug in our return to education equation and our full income constraint into our objective function, we get a simple equation that we need to maximize by choosing one and only one variable, which is S. All right, so let's do that. U of CS is equal to M times the log of Z plus Q ln C, which means M times A plus BS, that's plugging in our returns to education, plus Q times the log, I'll use a bracket, WT plus Y minus W plus P times S. Now I'm going to maximize all of this by choosing S. It's the only choice variable I have left, having plugged in all of my constraints. So max U of CS by choosing S. It's the same as then differentiating all of this equation with respect to S and setting that equal to 0. And so when I do that, I wind up with M times B plus negative Q times W plus P divided by my endowment minus the spending that I do on education, otherwise known as my consumption, the thing that gives me leisure. That equals 0. So I can just rearrange that then, and I get an equation for the determination of schooling. The amount of schooling I choose is equal to WT, so my endowment, divided by the cost of schooling. So that's the amount I could potentially spend on schooling, less Q, the weight I put on consumption today, divided by the parent's valuation of the return to education. So this is lovely because it allows me to think, to identify what are all of the things that are going to feed into the determinants of education. Higher returns to education should lead to more education, right? Because by increasing your denominator, this number gets smaller, making the sum bigger. Higher parental valuations of those returns to education will also make this number here a smaller one, increasing schooling. More weight on current consumption will tend to lead to less schooling. Higher endowment incomes will lead to more schooling, and more costly schooling will tend to lead to less schooling. That point that we made earlier about the impact of a change in the direct cost of schooling differing than the impact in the change of opportunity cost of schooling or change in wages should be easy for you to show mechanically by taking this function and differentiating it once with respect to P, so the direct cost of schooling, and then second with respect to W. And you should see that when you look at how families are impacted by change in W, you'll have the same effect as they are impacted by a change in the direct cost of schooling, plus that extra endowment income effect that yields a further or different response depending on what you think about the nature of that endowment income effect. So this is a fun little model. We'll use this model now throughout the education discussion, we can also use it for child labor simply by taking the optimal amount of schooling and remembering the time constraint we had, which is that your time endowment is divided between work and schooling. So what do you need to do? Well, to figure out the optimal amount of labor, you just plug in the optimal amount of schooling and subtract that from the time endowment, so that you wind up with, L star is equal to your time endowment minus WT plus Y over W plus P plus Q over MB. And there's your choice of child labor too. So this gives us a nice framework to think about everything we're going to think about for the next 2 weeks.